Hi guys, so today we're going to be doing problem number 26 of the 2019 local exam. This is another kinetics problem, and we have a sample of 0.9 moles of N2O, where it's decomposing irreversibly into N2 and O2 gas in a first order reaction, okay? And after 42 minutes, we have 0.64 moles of N2O left, right after it's beginning to decompose. So how long will it take for the reaction to be 90% complete? Okay, so we're looking for a time. Okay, but before we get to that, let's write the integrated rate law for a first order reaction, which is going to be the natural log concentration of A This is the initial concentration. So we're given that the initial concentration, well, it's in a sealed container, right? So the volume is the same throughout. So we can just use the number of moles as a concentration because they'll cancel out because it's the same. So it doesn't really matter. So let's just write 0.9 here. So the natural log of 0.9. Plus negative k. We don't know what k is, right? We don't know what the rate constant is. Times time. Okay, so we're given this in minutes, and the answer choices are also in minutes, so we don't need to convert to seconds. So we have 42 minutes here. And the natural log of 0.64 moles, right? So if you subtract the natural log of 0.9 and then divide by 42, and then put a negative sign here, we should get what k is. And k should equal 0.64 minus the natural log of 0.9. Okay, so that's equal to something, and then we divide by 42. So we get, and then remember the negative. This is negative overall, so when we put a negative sign, it's going to be positive. So we get 0.0081 for k. Yeah. So this is our k value. And this is going to help us figure out how much time it's going to take for the reaction to be 90% complete. Well, this is just a decomposition reaction, so there's nothing crazy going on, right? So if it's 90% complete, then how much do we actually have? Well, we have 10% left if 90% is already decomposed. So we're going to be dealing with 0.09 because 0.9 divided by 10, multiplied by 0.1, right? So 10% of that 0.9 is just 0.09, right? So that's how much we have left because 90% already decomposed. So we have the natural log of 0.09 is equal to the negative k. Well, we know what k is. So it's going to be the negative 0.0081 times the time, which we're trying to figure out. And then we add the natural log of the same initial concentration. So so the natural log of the concentration is equal to negative kT plus the natural log of the initial concentration. So let's subtract the natural log of the 0.9. Okay, let's subtract that, and let's divide it by the 0.0081. Okay. Let's just divide that by 0.0081, and then we'll see what we get. And don't forget the negative sign here. Okay, so we're gonna get t, right, once we solve that. So it's a natural log of 0.09 minus the natural log of 0.9 and then we divide that value by negative 0.0081. Okay, so we get negative 10.5. Oh no, we get positive 10.5 actually. Wait a second. Okay, yeah, we get 284.27. Okay, so D is our answer.